Push, and this can be presented by Jaehyun Han from UIST.
Yes. Thank you for the introduction. And hello, my name is Jaehyun Han, and I'm glad to present my work, my study. And my study introduced a new concept of touch operations named push-push. It allows users to oh, yes, sorry. Wait a minute. Yes, it allows users to conduct the page transitions while conducting a direct-line operations. So by utilizing hover and pressure sensing. And actually, operations on the conventional GUI can be overlapped with the other operations by utilizing additional input modalities. So by using overlapped operations, to conduct the subtask concurrently, the users can perform their primary task more effectively. In the first case, users can scroll the pages while selecting a text by using a mouse wheel. In the second case, users can rotate an item while while moving an item. So this diagram shows the concept of the overlapped operations and for scrolling pages while selecting a text on conventional GUI. And users select the text by dragging operation with the mouse left button, and concurrently they can scroll the pages by using a mouse wheel. But on the other hand, the operations on touch interfaces cannot be carried out while conducting other operations since they have limited input modalities. So the conventional touch interfaces usually use the state of the touched finger, so users have to repeat this kind of two operations. And the typical example of needs for the overlapped operation on the touch interfaces is page transitions while while conducting a direct-line operations. However, as you can see in the video, it is difficult to distinguish the page transition operations from the direct-line operations because they have similar finger movements on the touch screen. So users have to switch the mode to operations, or they have to trigger the additional GUI handles. So in this paper, I proposed a new direct-line operation named the push-push. So as I mentioned, it provides it enables users to conduct page transition operations while conducting a primary task. So in the following slide, I will describe the design of push-push and discuss the result of user experiment. And this figure shows the traditional two input states of the traditional touch interfaces. And to design a push-push operation, we opt to add two additional input modalities to the touch interfaces. And we named the spaces near the touch screen as a hover zone, and the device will track the position of fingers in the hover zone. And we also utilize pressure on the screen to distinguish the gestures with normal pulse from the conventional touch gestures. So to sense the finger in the hover state, we use the proximity sensing capability of commercial smartphone. And to sense the pressure on the screen, we attached 4 FSRs on the back of the devices. Actually, there are some smartphones with pressure sensing capability, such as iPhone and BlackBerry Storms. So using these modalities can be a practical solution for designing new touch operations. And by using these four input states, many design options can exist, and the details of them was discussed in the paper, but I not explain it in the presentation. And push-push was our pioneer design among them, and it was chosen because it may have less compression with conventional touch gestures and can minimize the unintentional activation and cancellation, and it also reduced the laborious operations. In the push-push, and two push gestures start and end the drag-like operations. And as you can see in the video, a push gesture consists of actions that press the screen and release the touch. And it is activated when applied pulses on the screen exceeds some threshold, and it is not timeout-based operations. And we named the interval between two push gestures as a glue state. And the glue state is kind of curse mode, so it is maintained when a finger stays in the hover state. And in the glue state, the user can conduct the traditional touch gestures since they can release the touch state. So I will show you a sequence of push-push operation. And dragging is started with the first push, and it is maintained even if one conducts the flicking gestures, and finishes it when the second push is occurred. Actually, push-push has an assumption that a finger will stay in the hover zone when one conducts a successive touches for unit task. Let's imagine the finger movement while you're repeating scrolling gestures to navigate the web pages. And we conduct the observational study to determine the attributes for the glue state. And by investigating users' behavior in the hover state on the touch interfaces, we try to minimize the compression with the conventional touch interfaces. And participate in the observation, participants have to use the conventional applications such as a web browser and messaging app and gallery and etc. And to track the relative position of fingers from the device, we attached markers on the finger and the devices. And the Android touch events were injected to distinguish the hover and the touch state. And we also record the video to observe the context of users. And six students are participating in this observation, and we get over thousands of data. And this data consists of successive touch events for a single task. So, and we extract two pictures from this observation. First one is a maximum distance. And the maximum distance of fingers from the device surface between two successive touches is our first picture, and the time interval between two touch events was our second picture. And the maximum distance between two successive touch events were usually less than 20 millimeters. So we decide the thickness of the depth hover zone as 20 millimeters. And the successive touches were occurred within about 1 second. So the timeout was, the outstate was started after a finger leave the hover zone over 1 second. It was used to minimize the accidental cancellation of the operation. So about 99% of the data satisfy one of these attributes. And with the decisions for the glue state, and we compared the push-push to the other two techniques that was commonly used in the current smartphone OS. And the etch technique is similar to the operations for dragging an icon in the widget pages. And the handle technique is similar to the operations for the selecting text in web browser. And 12 students participate in this study, and they hold the device with their dominant hand, and they conduct the task with their thumb. And the task for the experiment was moving an object to the target location. So I will show 3 techniques in a video. And for the push-push, the first push select an object, and second push dropped it. And between two pushes, user can scroll the pages by scrolling and flicking gestures. And for the edge technique, the users can select an object by long press, and they can scroll the pages by staying at the edges of the screen. The speed of the scroll was 2 pages per second, and they have to stay in the edges about 300 milliseconds. And for the handy condition, user can select the object by long press, and the control handle appears after long press, and they can move the object by dragging on control handle, and they can scroll the pages by touching outside of control handle. And this video briefly shows the experimental result. Using push-push has an advantage on the performance and subjective opinions from participants. And I will discuss the details. And for the mean completion time along the page transitions, the push-push was faster than other techniques when a page transition is required. And for the mean completion time along the target sizes, and push-push also had an advantage on performance while selecting a small targets. So actually, some participants mentioned that selecting the small target with less occlusion was an advantage of using push-push. And push-push was enjoyable and preferable than other techniques. And participants mentioned that they felt that no waiting time for selecting an object or flicking of pages was made push-push more preferable. And we also measured the workload by conducting NASA TRX after finishing each technique. And the push-push causes lower workload than other techniques. And among 6 factors of NASA TRX, the temporal demand was significantly lower than others. And there are some discussions for this experiment. Actually, though participants mentioned that any difficulties raised by the unintentional activation or cancellation of the operation, actually they will happen about 0.03 times and 0.01 times for each task. And most of errors will occur with some participants. So the precise calibrations for personal calibration may reduce these errors. And we also extracted the mean duration of the push gesture. And actually, the mean duration of push gesture was similar to the timeout for the long press. But some participants mentioned that they felt no waiting time while conducting a push gesture, so it makes a different user experience. And we also implemented 3 application scenarios with push-push. The first scenario was selecting a text, and so users can scroll the pages while selecting a text. And second scenario was dragging an icon, and so the users can conduct the flicking gesture to transit the pages while dragging an icon. And the third scenario was drawing a selection box. So users can scroll the contents while drawing a selection box. So users can select multiple items together. So we also implemented these application scenarios and they compare it to the traditional touch gestures. So the result of this experiment also showed that the push-push was advantage on conducting primary tasks when a page transition is required. So I think I quickly stopped it, and thank you for listening. So.
Okay, I'll start with a quick question. So now that we're seeing force sensing starting to appear in devices like Apple's 3D Touch, it's probably going to be increasingly that we're going to see sort of force or kind of press-related gestures appearing across the entire operating system. So do you think there is an opportunity or a danger with the kind of gesture set you're proposing, like how that's going to integrate and still be kind of recognizable and discoverable by users?
Would you cast?
So if, like on Apple's new phone, where it has press force,
Yes.
they have their own sort of gesture set.
Yes.
How do you see your gesture set working in combination?
Actually, I heard that the posters in iPhone can drag on object by push it, and by maintaining the push it, and they can drag the item. But while doing that, when the user releases the touch, then the operation is finished. So to transit the pages, there is another technique is required while conducting this kind of operation. So in that manner, my operation has an advantage on that kind of thing for that case.
Okay. And, Gregory?
Hi, Gregory again. So in the beginning when you showed with traditional ones, you showed some examples of rotating while, and it had me thinking, have you explored any kind of multi-touch things where you might do the push-push with the thumb and the other finger is doing something else like a rotation or zooming while you're doing action, so you could look at more sophisticated things rather than just selecting while panning?
The main concept of this operation is conducting a subtask while conducting a primary task. So the push-push is an example of this kind of concept. So it utilizes the page transition operation as a subtask, and the dragging-like operation is a primary task. But as you mentioned, that using another gestures using multiple fingers can be another way to applying my concept too. Thank you.
I'll just ask one quick follow-up question. So, one of the very nice things about multi-touch is that the gestures were very discoverable.
Yeah.
So this, may be a little hidden at first. So maybe you can just comment on how you think users will find out about this ability to push-push?
With the multi-touch?
Yeah, like how will people know that they can perform this action?
Actually, when I conduct the user experiment, then I have to explain the push gesture.
Mm-hmm.
So after few trials, then they can understand the push gesture and they conduct this operation very well. And actually, maybe 5 minutes trials, and with 10 or 20 times of this operation, they can conduct this push operation without unintentional activation or cancellation. So in that manner, it works fine.
Okay, let's thank the speaker.
Thank you.